Before we begin the lesson on area and perimeter of triangles and parallelograms, I would like for you to take a minute, pause the video, and just write and tell me how you would describe area. Following the steps below, I'd like for you to draw a rectangle or a square using the coordinate plane. Now I'd like for you to find the length and label each side. So find the length of each side and then label each side. This can be done by counting the coordinates because we have horizontal and vertical lengths. You don't need to use the distance formula. Now I'd like for you to count the squares that exist inside your square or your rectangle, whatever you choose to draw. And of course, record the number that you counted here. After you've counted the squares inside your rectangle or your square, and what I mean by that is 1 square, 2 square, 3 square, all the way through. Then I'd like for you to multiply the length, so it doesn't really matter which one you call length, and the width together of your rectangle or square. So for me, it would be 12 times 6. So what do you notice? Take a minute and reflect on what this means. So what you did originally was count the total area that was inside the rectangle or the square that you drew. But the shortcut is that you just take the side lengths, 12 units and 6 units, or whatever you chose, and multiply by each other. So here, the area of a rectangle, the shortcut is you multiply length times width. Or the area of the square, if you chose to do so, would be you take the sides and you square them, or it's the same thing as doing side times side. A parallelogram, if you were to find the height of the parallelogram here, the area would be base times height. And you just have to be careful when you're using a parallelogram because the height is not the diagonal here, or the slanty side. The height is the perpendicular to the base. And then we have the area of a rhombus. And the area of a rhombus is taking 1/2 the first diagonal, the whole thing, times the second diagonal, the whole thing. Now, I'd like for you to go back up to your coordinate plane and draw a diagonal on your rectangle or square, dividing the parallelogram in half. So we're going to draw a diagonal with our straight edge, dividing the rectangle or the square in half. What shape did you form by doing this? Notice the area of your triangle up here is going to be half of your original area of your rectangle. So for me, it's half of 72, or half of the base times the height, which will give me the area formula for a triangle. So here are the formulas that you're going to need to know for this unit. And now on the next page, we're going to apply them. But in order to apply the formulas, you're going to have base and height used a lot. And sometimes it's confusing which one is the base and which one is the height. The thing you need to know is that the base and the height are perpendicular to each other. So you find your perpendicular, that's your height, and whatever side is basically adjacent to that height is your base. Well, in this first triangle, we don't have anything perpendicular, so we would end up creating it. So this would be our height. And because we drew the height perpendicular to the side with the 2 on it, this would be our base. So the area for this triangle would be 1/2 base times our height. Now we have a parallelogram over here. They gave us side of 5, which is the slanted side, so we're not going to use this for our base or our height. The base and the height are perpendicular to each other. So 4 would be the height and 10 would be the base. The 5 would just be there to throw you off, or if they gave this to you and they didn't give you the height, you could use it to find one of the missing lengths of the sides. So let's come back to this equilateral triangle. How would we find the area and the perimeter? Well, let's start with the easy one, the perimeter. Remember, perimeter is walking distance, or how far around the triangle it is. So there's a length of 2 here, 2 here, and 2 here. So there's a total of 6 units around the triangle. Now the height is necessary. We need the height because the area is 1/2 the base times the height. Well, in order to get the height, we're going to have to use special right triangles. If we want this to be a right angle, and we know that this is an equilateral triangle, remember each angle in an equilateral triangle is 60. And then up here it's been cut in half, so it's 30. So we end up with a 30, 60, 90 triangle. Well, we're looking for the height, and we have opposite the right angle, so that's equal to 2t in our 30, 60, 90. So t is equal to 1. And 30 opposite the 30, we don't need that one. We need opposite the 60. Opposite the 60 is t square root of 3. So this side, this height opposite the 60 is just 1 square root of 3. So our formula, 1/2 base times height, where our base is perpendicular to our height, so it's 2. And our height, we said, was the square root of 3. So the area of our triangle is going to equal 1.7. We'll just say 1.7. We'll stick with the round to the nearest tenths. Okay, so I'd like for you to try number 2. This time it might be easy for you to draw your altitude here. So we're looking for the height, and we know that this is an equilateral triangle. Pause the video and see if you get what I get for the area of the triangle. And you should have gotten the area is 15.6. If you didn't, raise your hand or ask a neighbor. Now pause the video and see what you get for the perimeter of the triangle. And the perimeter of the triangle should be 18 units. Number 3, we're going to be utilizing special right triangles again. We're going to assume that this is a square. So if this is a square and we have an altitude drawn within the square, it's going to be a 45, 45, 90 triangle. Opposite the 45 is n, and opposite the 45 here is n, so this is also 4. And if this is 4 and this whole thing is a square, this is also 4 here. So this side is 8, which would make this side 8, this side 8, this side 8. So the area of the square would be 8 times 8, base times height, so 64. And the perimeter of the square would be 8 times 4, which is 32, adding up all the sides. Okay, you're going to do the same thing for number 4. You're going to use special right triangles to find this missing side, and which will also be the length of this missing side. Pause the video and see if you get what I get for area. And so for the area, you should have gotten 128. If you didn't, pause the video, raise your hand, and ask me or ask a neighbor. Now, what I got for each side here was 8 over the square root of 2. So this right here was 8 over the square root of 2. So the whole thing, if I added them together, was 16 over the square root of 2. So each of these sides is 16 over the square root of 2. So pause the video and make sure you get what I get for the perimeter. For the perimeter, I got 45.3. Okay, the next examples we'll be solving basically backwards for either a length, a width, a height, something like that. Now the first one is the area of a rectangle is 20 yards squared. So we write down what we know. We already know the area of a rectangle is length times width. Well, they said the area is 20, and that equals length times width. If it is 5 yards long, so here they gave us the length, which is 5, find the width. So we're just solving an equation, finding a missing variable. So the width in this case is going to be 4. Alright, I'd like for you to try number 6, pause the video and see if you get what I get. And we should have gotten the base is 24 units. Number 7, we're given the diagonals of a rhombus are 26 and 11 centimeters long. So remember, the formula for the area of a rhombus is 1/2 diagonal 1 times diagonal 2. So this one's simply a substitution formula. You take 1/2 the first diagonal times the second diagonal, and it gives you the area. So you should get an area of 143 centimeters squared.